Hold on, December the 3rd. All right, let's do this. Make string a subsequence using cyclic increments. You're given two zero-indexed string. In an operation, you select a set of indices in the string 1, and for each index I in the set, increment string 1I to the next character cyclically. Return true if it is possible to make string 2 a subsequence by performing subsequence of string 1 by performing the operation at most once, and false otherwise. So we can only do it once. Oh, subsequence. It's not substring. Okay. Yeah, I forgot what subsequence is. Okay, yeah, then it works, right? So we have A, and then we just need a D, and C can turn into a D. AD. So each one can move once. So each position, right? Basically, you're saying each position, I can move row forward once or 0 times. So this one row forward will be A, row forward will be D. And this is not possible because none of them can become D. Okay, so oof. Let's see. Well, a few easy cases we can take away. If string 2 is longer than string 1, and that's not possible, right? And we want to make string 1 the same, not the same, string 1. So maybe 2 pointers. No, string 1 we have a pointer. String 2 has a pointer, and we're going to try to match. And the earlier you can match, the better. This is kind of a bit greedy here, because the more to the left on string 1 you can match to string 2, then the more chances that you can match other things on string 2. So basically we're saying is if you can match it early, do it. Right? If you cannot match it, then yeah, there's no other way. Yeah, if you can match it early, yeah, just match it, right? And if you choose not to match it, you can match it later. You can always match it earlier. So yeah, this is kind of a greedy idea of doing this. And so we both start on the front, and then we just see if it matches. So basically, for each index in string 1, we can do 2 matches, right? One match itself, or you can match the one after it. So you try it, right? You try to see, okay, do they match? And if they do not match, if +1 match, if they match, then we move on string 2, right? And we will keep going until we match everybody. I think that's it. I honestly think that is it. I don't think there's any other trick in this. We just 2-pointer it, and then we'll call it a day. Actually, no, I think if that is the case, then we can move on to something else. But I want to make sure, okay? I want to be sure. I want this to make sense. Would it be a situation where the 2-pointer? Nah, it's 2-pointer. I mean, I don't see any other way. This is just 2-pointer. This is just 2-pointer. All right, so let's get it on. 2-pointer. Oh, we need to first save this. Okay, and then we have string 1, string 2. We can say int I. Oh. Yeah, let's just do this. Int j is 0 as well. And while I is smaller than. Actually, no, we can go I forward, right? And then we just check. Yeah, okay, let's do this. We have j, and then we can say for int I, 0i smaller than str1 dot. Okay, so hold a second. We shall say 224 12 0. No, I think 01. Using namespace td. Okay. So I don't have to miss this one. All right. So this is dot length, I++, right? And then we say if str2 j is equal to str1 I or str2 j is equal to str1 I plus 1. I can do plus 1, right? And I need to mod 26. I need to plus a. If that's the case, then we'll move j forward, right? We'll move to say j++. If not, then we just keep going, and then we return j shall equal to str2 dot length. All right, I have a lot of confidence in this one, so let's just get it on. This is 2825. 2 pointers. The only part that I'm not so sure about is whether that arithmetic is correct. But we have the test case, so we can check the test case and see if it works. It is not. Something is wrong. Okay, that's fine. Hey, I have debugger. That is so beautiful. All right, so we can actually do this. We can say std string one equal to. All right, which one? Oh, is this how you? Yeah, I think this is one way to initialize. We have ABC and AD. Okay, ABC std string str2 cd. No, this cd AD. Right, and have solution, and then we say this is can make str1 str2, and then we'll put save this, and we come here, C line plus plus. Have we done anything? Debug challenge. Okay, so we're gonna make some difference. No, I think we should still put in here challenge, call it main, and this one shall be what, 4, right? Okay, and then we come back here, we set a point, we do this, and then this is going to be main. Okay, let's debug this stuff. Let's see where we got it wrong. All right, well, what do we have? Which is F2. I think F2 is next. All right, and okay, I is 0, J is 0, right? So they're equal, so J shall plus plus. Okay, I also plus plus. There you go. And next is they're not equal. Okay. So next is not equal. I think it's the mod 26. I think that one is the issue. Hold on. I think the problem is here. It shall be this one minus a plus 1 mod then plus a. Okay. I think that is the one. In fact, I think I can come here, run it again, and then we run 224 12 challenge main. They shall return true. There you go. So mystery was solved. Oh man, I love debugger. Didn't use it very much in the past, and I feel bad. Right? You should use it more often. And why the hell it's so slow? Like, what in the world? It's 2-pointer. Like, how else can we make it better? I don't know. It's how do we make it faster? Oh, jump out early. Yup. Exit early if str2 has been completely traversed. Yes. And j is smaller than str2.length. Boom. We can significantly improve performance this way. Yep, didn't realize when I was doing it earlier, but now I think it's pretty straightforward that this one can do. I tried it first. It works. Now we submit. That should be like 1. I don't understand now. What in the world? It's even slower? How? Plus, how is this? Wait a second. This is weird. This is very weird. And how did I not get any error? Because I didn't really check if j is in or j is outside the range. Don't tell me it's because of this. This will be very stupid. If this is the reason, that would be so stupid. You gotta be kidding me, man. You gotta be kidding me. You have to do this in order to make it fast. Oh. Is that how C++ is? Is that how C++ is? Which means the call, it incurs a function call. Darn. Oh, this is smart. This is very smart. Holy crap. Further updates. Update 2. There is an easier way to do the logic. To do the logic of checking. So if it's equal, right? If it's equal to str1 I plus 1, or str2 j will equal to str1 I minus 25. Yes. Holy crap. Oh, this one, this will give me probably 1 millisecond. Let's see. Okay, I don't understand. I think it's because we did a one more check. Oh, C++ is interesting. This is exactly the same as this. Okay, let me try one more time. One more time. So basically, the other one is we do it once. Yeah, but this one's slower. But this one is slower. So let's go back to the previous one, which is equal to this, right? Plus 1 minus a mod 26 and plus a. Right, this is the other one. So you're telling me this is still faster. This, try one more time. This one's still faster. This one is still faster. And this one's the same as this, right? Yeah, it's the same as this. So this is the fastest. Okay, so we got 2 data points out of this. Number 1, function call is expensive. If you have dot length, don't do dot length. Get the value out. Second, if condition is expensive. If you can avoid using if condition, you do it. And especially, I think modular is faster than if condition, basically, because I have to do modular. And the other one doesn't have to do modular. And the modular takes less time compared to another if condition. Got it. Okay, so we're good. We're good with this? Are we not? We are. Okay, so we're done with this. Now I can look into this one. I forgot. What is this? Ith guard and J's wall. Can see every cell in the full kernel. So there's a number of unoccupied cells that are not guarded. Not guarded. So these are all guarded, 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 not guarded. So what I do? Put guards on what position in rows and columns. Sort them. And then check each cell and binary search to find whether the cell has an adjacent guards on a row. So basically, I put row, oh Jesus, row a hash map, column hash map. So each row I put because I have guards and I have walls. So for the guards, I get its position, right? Yeah, the guard's position. And then I put this. What is this? Whether you're a guard or whether you are a wall. And I sort both based on their position. And I binary search. Right? And I for each cell, I binary search because I want to know if the cells are good or bad. So for each cell I binary search and I check if to my left or to my right there's a guard, or to my top up or to my down is a guard. If there's no guard, then I am free. So rows dot contain keys. If it's yes, I say I'll binary search for the index. If it's larger than 0, it's occupied, which means it's not, right? Otherwise, we do this, so we get actual index, and then we'll check yes, if it's smaller than this, and then if it's equal to 0, which means it's a guard, or if it's larger than, so it's this is to the right, this is to the left, then we don't do it. And then this is the same, and then we to the top and to the bottom. If we pass this, then rest post. Okay, so I got what I was trying to do. Iterative simulation. Okay, what's the runtime for this? OMN. Really? Just go through this. How? So we get an occupied, and then, or we just go, hold on, let me think about it. If we go through the whole thing, left to right, we just count on roll, right? If I go, and so here's empty, boom, we hit a guard, then those are done, we reset, right? And empty is also reset, but simulate each guard's range of vision. Simulate each guard's range of mission. Oh my goodness, yes. For each guard, we go left, we go right. Just fill it up, right? We just fill it up. And yeah, and then for the next guard, I'll do the same thing. But how do you ensure that you don't double do it? Reach a guard's boundary, the grid's boundary, encounter another guard or a wall, which blocks. So I guess it's fine. So you just keep going. If you hit, then just don't go. But Hold on, let me see. Mark guard position. Mark wall. So we check, check, check. Really? That's simple. Because I was worried you might duplicate the effort. Well, I guess, yeah, you won't really duplicate the effort because if it's a guard, you go, it will at most, right, you'll duplicate, but it's not like, it's still m times n. It's still m times, okay. I think this one we can just do that. Recursive way. Same, optimized. Yes. Row by row and column by column. So for this guard, I go row. Right? And then, yeah, so I start from here. So, do we sort it first? Hold on, let me think again. So they say we do this row by row, right? So on a row, I start from sum and I mark it. It makes sense, right? So you just do this row, right? You do the row and you mark all the things that you cannot, that's guarded. And then if on the same row you have something else and you start going, once you hit some cell that has already been guarded, then you don't have to keep going. I think that's what it is. We can take a look. So you create a new, gosh, damn. Wait, it has to be vector. A vector of a vector. Wait. Hold on, how do you do this? A vector of a vector. Why is not a int array for this? Well, I don't know why, but if they say vector of a vector, then we do the same. So vector. So this is initializing a grid, which is the number of rows, number of elements, okay, m, and each one is a new vector which has n element and is unguarded, right? And then we'll put a guards in it, put a walls in it. Perfect. Helper lambda to update visibility. Wait, what the hell is this? It's a lambda function. What the hell is this? Row column is guard line active. So wait, hold a second. What is this syntax? Lambda function. C++ has a lambda function. Dude, this is new. It's called lambda expression. Okay, introduce lambda expression in C++ 11. Capture clause, parameter, return type. All right, capture variable, capture all external variable by reference. Oh, by reference, by value, capture by value, A and oh, okay. Lambda expression to print for each from start to end, and this is wait, but this one doesn't have. It's just empty. It's just empty. A lambda with an empty capture clause can only access variables which are local to it. So there's a local to it. So you don't pass things to it because it's called within this. So basically each lambda find if, and then we'll say return larger than instruction for iterator vector iterator p. Wait, really? Iterator p, and then you dereference it, and then you just go through the whole thing? What in the world? Sort. Count if. Oh, this already. Oh, this is a function call, so it's already aggregated for you. I see. Okay, so what are we using here? Is now this will capture everything as a reference. Oh, we capture everything as a reference. I see. So this is a reference. This is a reference. But I don't really. Is it really necessary? Hold on. Let me see one more time. So we pass this in. Now we say if it's a guard, return true. If it's a wall, return false. Oh, that's why it has to be a reference. Okay, horizontal pass is guard line active. You go from left to right. That's different from how I would do it. I was thinking about starting from each one, and then we just go left. We go until we hit a wall, we hit another one, or we, you know what? I think I'll do it differently, but yeah, this is definitely a thing to do. Okay. We'll do this some other time, but that'll be interesting. I never know. Wow, this is a new syntax. All right, I'll do it some other time. I'll see you guys tomorrow. Adios.